All right, today's notes, we're just going to start getting the idea of that measure of regression and how it actually kind of gets measured, because once we're done with today, I guess once we're done with today, I'm going to have you just kind of finish some stuff up on your own, kind of a little bit more manual calculation to kind of get some idea what your calculator is kind of doing. I think that helps. And it also will help you figure out kind of where R is coming from. Remember, or rho, right? That's what the population one is. But R is our sample. And again, that's the correlation coefficient. Okay. But we're also going to take a look at maybe finding that another way today. I believe I've given you on your notes the definition here, right? Total variation, right? So it says with regard to a regression line, because they have to be very careful, right? Because we've talked about variation before, right? It is the sum of the squares. Wow, this just sounds complicated, right? Of the differences between the y values of each ordered pair and the mean of y. Okay. So what I would like to do is maybe let's just stop for a second and let's talk about deviation for just one point. So let's say I had point x1, y1. And of course, if we're talking y values, the y mean would be y bar, right? If I just talked about one point, how would we find, symbolically, how would we find the deviation of just that point, or how far that was from the mean? Well, we would probably do some kind of subtraction, correct? Isn't that what we've been doing this whole time? And the way that we would probably do it, and the way we've been doing it, is we would say, let's take y1 minus the mean, correct? That's what we've kind of been doing, is stat minus parameter kind of thing, right? So this point minus the mean, that's how far that would be. Don't put that where the formula would go, just put this off to the side, you know. That's what we would do for each point, right? But what if I did that for each point? I found out how far each y value was from the mean, and I just did it like that, and then I added all of those up. Can you remember what answer I would get for that? In other words, the total deviation from the mean. No, I'm looking for a number, actually. If I took that for every single point that I gave you a bunch, and I took every one of them, I took how far it was from the mean, you would get, and I added them all up, you would get 0, correct? Isn't that why standard deviation had all its problems? And so what did we do with all of them then? How did we get around that problem? Very good, we squared them because that took care of all the negatives. Then we added them up, divided by how many we had, and then we took the square root, right? I mean, that's kind of what we did, right? Well, it's very similar in this case, except they don't say y1, y2, y3. They just say y sub I, whichever one you're on, right? Subtract it from the mean, and then square it, and they did sum. So what does that look like? How would you write that? It says take them from each other, and it would look like that. So take y sub I, meaning all of them, y1, y2, y3, all of them, right? Subtract it from the mean. Again, some of those will be positive, some will be negative, but we know the total, if I add them all up without squaring them, is 0. So that's a problem. So what we're going to do is we're going to square them and then add them up. Okay, does that make sense? So that's total variation. That's how much the values we're looking at, the y values we're looking at, differ from the mean. So that really shouldn't sound too different from things we've been doing all year. We've been comparing things to the mean quite a bit. Here's something, though, that is definitely new. It's called explained variation and unexplained variation. Okay. And this is very commonly messed up by students. So explained, it tells us sum of the squares again. You can probably figure out why we have to square them, right? Of the differences between each predicted y value and the mean of y. Well, what's our predicted equation? What do we start that equation with? You almost tried to say it for the other one. Our prediction equation, what do they use? Y hat, right? So we would call that y hat 1, y hat 2, y hat 3, right? Those are all the ones we would get out of there from the mean. So that one looks very similar. It says y hat I, which stands, we would do 1, then 2, then 3. From the mean, again, if we were to do that and then just add them up without squaring them, we would get 0. So that's why we square them. And why don't you take a second and read unexplained variation, and then maybe underneath or something off to the side, try and write the little equation yourself. What would that look like in symbolic notation. So just take a second and try it. All right. Well, what's probably the first thing you wrote down? Yeah, sigma, right? We got some sigma going on here, right? There it is. Then probably what? Yeah, parenthesis, right? Because it is important, that parenthesis, though. Without it, this isn't quite the same thing, right? Then what? yi, because that would mean the y value. I wish I could get rid of that thing, though. It's really kind of annoying. Oh, there we go. yi minus. You didn't sound very convincing. Do you agree with it? Y hat I, parenthesis. Again, if I were to do that right there, what do you suppose we would get? 0, right? Or relatively close, depending on rounding and whatnot, right? Squared, very good. Now, looking at them like this, it is very, very difficult to see. And that's why in the back, and that's why I also put the colored pencils out there, we're going to kind of color code some things on the back, and that's going to be the one thing I'm going to have you finish up for today. We'll kind of look at it that way. But one thing before we go and do that I want to cover is we're basically going to figure out, one of the biggest things we have to find out is how much of this variation can be explained by our line. That's what we want to know. How much of this stuff going all over the place, the variation, how much of it can be explained by my line? Because the more of it that can be explained, the stronger the correlation is going to be. You see what I'm saying there? And the more of it that's all over the place and I can't really explain why things are going there, well, then the correlation's not going to be very good, is it? If I can't explain it. Okay? And what do you think? Explained variation plus unexplained variation better equal, not necessarily 1, but total variation, right? If the total variation is 1, then yes, they better equal that. If I add the two together, they better be total. Because some of it's going to be explained, the rest of it better be, But that gets a little weird depending on where your points are, and that's one of the things I want to point out on the back. Okay? But before we do that, we're going to do what's called the coefficient of determination. Whoa, that sounds like a mouthful. But it is a letter we've seen before. It's R. What was R in itself again? Had the word coefficient in it. I know that doesn't really help. Well, what did it tell us? It told us the strength, right? The closer it was to 1 or -1, it told us the strength and direction, really, right? It's the correlation coefficient. So this is basically the correlation coefficient squared, correct? And this is very important. It is the ratio of the explained variation to the total variation. So symbolically, looks like that. So I look at it as that this is almost like a percentage, correct? Because explained is just some of it, right? Over the total. So we know some kind of limits to this value, right? Because can explained be more than total? No. So this is going to be somewhere, if we're talking percentages, 100% or less, right? Between 0% and 100%, right? Now, some people in the past have told me that it could go negative, and I said, well, you might want to look at your values again, right? Because they're squared, right? You with me on that? Well, good thing that this has to be positive, right? Because if I have r squared, and I know that value, how hard is it to get r? Not very hard at all, is it? Okay. So realize if this ratio is flat out 100%, what that means is that my points do what? Because we're talking linear here, right? If this ratio is 1, comes out to be 1, that means 100% of it can be explained by the line. Yeah, it means there's a line, okay? And you notice, like before we said like 0.9 and all those values were really strong, right? Now you kind of see why, because almost all of it is explained by the line, okay? Now you start talking the quadratic one or the curved one, this probably isn't going to be as strong if we're talking linear, right? This one I'll give you a chance to write down. This one I'm pretty sure is on your little, this one's nasty. And I'm going to see if we do a whole lot of problems this way. I kind of look at it this way. Well, yeah, I guess that's it. This is kind of your unexplained y. Here's your unexplained x, right? That's really what it is. So you can write that down if you want, but I'm pretty sure this will be on your sheets. I'll give you a second to do that. We would kind of use that more if we were looking to get a confidence interval for my line, like, you know, because again, this is the standard deviation of B1. And what does B1 stand for again from all our other notations? Slope. Yeah, y-intercepts B is 0, BO. So yeah, this is if we wanted to kind of mess with our slope a little bit, saying the slope has to be between a quarter and a half, and then we're good. But so that could be important, but we'll see how much we do on that one. That'll be good. I can always put that back up later if you want to see it. So here's what we're going to do. Here's our points. So we have A, B, C, D, E, and F sitting up there. I put them at pretty nice points. I know some of yours are hard to read. I was looking at it the other day. You see how my X values are going up by a half? Right? 0, half, 1, 1.5, right? And my Y values are just going up by 1. You with me on that? So I have skewed the graph a little bit, right? So imagine putting this back in at the same scale. Okay, I know that's kind of hard. But what do you think about this particular correlation here? Do you think this is pretty good? Strong, weak, medium? What do you think? Again, I have skewed it a little bit. Because realize if I were to get it the same, I'd either have to stretch the y-axis a little bit to make it the same, right? Or shrink the x. Are you with me on that? To make them the same. So I have distorted it a little bit for a purpose. Okay. So if you stretch that y, E and D kind of get a little goofy, huh? I would go with kind of a medium. Although, again, you have to watch out for the scale, right? Because right now, if this was a 1-to-1 scale, this is pretty good actually, right? But it's not. It's kind of like a 1-to-2 scale. And actually, I made these points so that it came out to a nice linear regression. That actually is the line of best fit right there. Okay, I've actually found it. And let's face it, we could do all the math to figure that out. But please notice that the origin's over here, right? You with me on that? So I know my y-intercept is 2, right? And so if I'm going to find the equation of this line, what's something else I probably need? The slope, right? And so it looks like this is a point, right? And another point is way over here. Now I made that look like 0, 0, right? Those green lines are in there for a reason. We'll talk about that in a second. Well, what point actually is that? The red one I just made is 4, 3, right? So we're going from here to there. So it's up 1 over, how far really? Up 1 over 4, right? So the slope is 1/4. So what's the equation of this line that we have here? Yeah, so y hat, right, equals 1/4 x plus 2. So what are these green things I got floating around in here? Yeah, it's the means. Yep. Now let's face it, we could sit here and add up all these y values and divide by how many we had. Finding that probably wouldn't be that hard, right? Add up all the y values. So this green one right here going across is which one? This one is x bar or y bar? Y bar, very good. And then this one down here is x bar. I guess really for the one we're doing here, I didn't really need to do x bar, but if we're doing standard deviation, I would have to. So again, I see a lot of points kind of in what would be considered if you use x bar and y bar as the axes. I see a lot kind of in the third quadrant and quite a few in the first quadrant, right? And that one kind of straggling over there in the fourth quadrant, right? So here's what we're going to do. We're going to actually go ahead and we're going to find total variation, and we're going to find explained, and we're going to find unexplained, and we're going to color code it. You color code it however you want. All right. So let's do point A first. Seems to make sense. We're also going to do point B because point B is actually one of the strange ones that causes people difficulty. Okay. What do you think about B makes it a little different? What do you see there that might make it a little different? Anybody? Or is everybody still digging for their colored pencils? Yeah, B's right on Y bar. That gets a little interesting, a little harder to explain sometimes. All right. Everybody ready? So let's do total variation. So we're at this point here, point A. So total variation, remember, is how far my Y value is from the mean. So is point A a distance from the mean? Yep. I'm going to represent that in blue. You represent it in whatever color you want. But make yourself a label somewhere off to the side so you know which one's which for you. Or do you all have different? I could always probably change my colors. But so here we go. I'm going to do total. Now this is just deviation, right? TD, total deviation, is really for point A. Well, where am I at? My Y value is actually 2, correct? Minus the mean, which is, what is Y bar? 3, right? So according to this, it would be -1, right? And that distance is represented with this blue line, right? Do you agree that is -1 away from the mean, correct? So that's what deviation means, right? How far it is from the mean. Okay, I missed a little bit, but that's all right. So that's total deviation for that one. So I'll go green, and let's do explained. Now I know on the other side it says variation, right? But that's because we've added them all up, right? This is just deviation because I'm just doing one of them. You with me on that? Explained deviation is how far, this is probably the trickiest part. Explained, now remember, I'm trying to explain my line, right? So that's why we would say the explained is how far it is from, say, my prediction line to the mean. Okay? So here's my prediction line, is right here, right? To the mean. So that represents the explained deviation. That much of it can be explained. Does it explain all of it to the point? It doesn't quite explain all of it, but it does get a good chunk of it this time, doesn't it? It gets a good portion of that blue line, doesn't it? Okay? And so what is that value? Well, we know we got to go find that value. How would we find this value right here? Well, we know the x value is 1, right? So how would we figure out that prediction line? We'll put 1 into the equation, right? So you put 1 right in there. And so what point are we actually looking at? What's that actual point right there? It's not actually 2, is it? It's actually 2 1/4, right? So that would be, well, I'm going to run into my x bar there, right? So it'd be 2 1/4 minus the mean, which is 3. Do you agree that that looks like a -3/4? That distance I just drew in green? Yeah, okay. Yeah, I'm going to get in the way. I'm going to erase that one. -3/4. All right, so now let's use our knowledge here. Based on what we've drawn so far, we put total variation in blue. Right, that's how far my point is from the mean. We put explained variation is how far the prediction line is from the mean. So of that blue line, I got a good chunk of it, didn't I, this time? So where's unexplained then? Yeah, from the line to your actual point, right? So from the prediction line to your actual point, I'll do that in red. So that's that distance, right? That's unexplained. So is there a whole lot that I can't explain this time? Not really, right? But remember, this line came from considering all the points, correct? And do you agree that y bar came from considering all the points, right? Now this is just considering this point. You with me on that? Okay. So where are we at here? Well, I got to find out how far is that y value from the prediction? That y value is actually 2, right? Minus the prediction, which is 2 1/4, right? And so we're at -1/4. What did I tell you about explained and unexplained? They better add up to total. Does that make sense as you see it? Okay, my point, and I think the hardest thing for people is to realize that y bar and my prediction are taking all of the points into consideration. I'm just looking at one of them. Okay. Questions on that? All right. Again, as it was said, I pointed out that B was probably going to be one of the strange ones. Another one that's probably going to be strange, well, there's actually a couple more that'll be strange. How should I put it? When your point and your line are on opposite sides of the mean, that gets a little weird. Okay, do you see what I'm saying there? Where this time my point and the actual prediction line were on the same side of the mean. When they're on opposite sides, that gets a little goofy. So D is going to be maybe one of your stranger ones. Okay, it'll still work though. Okay, so here we go. Here's B. So what's total variation again? It's how far your point is from the mean. Yeah, so in other words, 0, right? Because how far is B from the mean? Well, it's smack dab on it. So my blue line is like a blue dot, right? So for this one, total deviation is nothing. Okay. And explained we did in green. And this is probably the most important one. Explained is really how far my line is from the mean. So does explained really have a whole lot to do with my point itself? No, explained is the only one that has really very little to do with that point, except you're looking at that particular x value, right? So how far at that particular x value is my line from the mean? Well, it happens to be that distance, right? Just happens to be because the point's actually on the mean, right? So for that one, we would take whatever the prediction equation is, and so then we would put 2 into our function, right? Right. So it's 2.5 this time. Is there see where 2.5 came from? So I'm putting 2 in there because that's there. So it's 2.5, right? Minus the mean, which is 3. And one thing you can always remember is if you are using mean at all, it always comes last, right? Subtract the mean, right? Is -0.5. Because, let's look at it this way, everybody, up here. This point on the prediction is actually below the mean, correct? So that's why it's negative. Now the last one is how far my actual point is. This is the explained, so I better do it in red. The explained, or I'm excuse me, unexplained deviation is how far my point is from the prediction equation. My point happens to be above the prediction equation, correct? By how far? By a half. Okay, see how this one's weird? How we're drawing that same line a bunch of times, right? But this time it's a positive half because it's above it, right? So how far my point is? Well, my point's at 3, right? Minus the prediction, which is 2.5, is a half. So even though this is an oddball, because it was smack dab on the mean, do you see how adding the 2 still does work? I think for tomorrow, I would like you to finish C, D, E, and F. Get total, explained, and unexplained. Yes, you may keep the colored pencils. Well, for now, not forever.